When people talk about access control casually, they often collapse everything into one vague idea of permission. Yet secure systems depend on a much more disciplined mapping between what someone is responsible for and what they are allowed to do. In this episode, we're going to connect three related concepts that beginners frequently mix up: roles, rights, and responsibilities. A role is a defined function in an organization or system, such as analyst, approver, administrator, or service operator, and it helps group similar access needs. Rights are the concrete permissions granted to an identity, such as the ability to read a dataset, change a configuration, or approve a request. Responsibilities are the duties and expectations attached to a role, including what outcomes the role is accountable for and what actions the role should be able to perform to meet those outcomes. Mapping these correctly across systems, applications, and data is the heart of authorization design because it prevents both over-access and under-access. Over-access creates risk by letting people touch things they do not need, while under-access creates operational friction that drives unsafe workarounds. By the end, you should be able to explain how architects translate responsibilities into rights, how roles help keep that translation consistent, and why data access often requires finer thinking than system access. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A practical place to start is by imagining the difference between what an organization expects someone to do and what a system technically allows them to do. Organizations describe expectations and responsibilities, often in job descriptions, policies, and workflow definitions, while systems enforce rights as specific allowed actions on resources. If those two do not match, you get predictable failure patterns. If responsibilities require an action but rights do not allow it, the person cannot do their job, and the organization will either grant broad access quickly or find informal workarounds like shared accounts. If rights allow actions that are not part of responsibilities, the person may accidentally perform harmful changes, or an attacker who compromises the account can use the extra rights to move deeper into the environment. Roles sit in the middle as a way to standardize the mapping so that access is not decided individually each time from scratch. The key architectural idea is that roles should represent stable sets of responsibilities, not personal preferences or temporary project needs. When roles represent stable responsibilities, rights can be assigned consistently, reviews become meaningful, and onboarding and offboarding become safer. For beginners, the main insight is that access should be justified by responsibility, not by convenience, because convenience-driven access is how permission sprawl becomes permanent. Now consider why mapping has to happen across system, application, and data access, because each layer behaves differently. System access usually refers to the ability to interact with infrastructure or platforms, such as managing servers, accessing network segments, or using administrative consoles. Application access usually refers to capabilities inside a specific application, such as creating records, approving actions, or managing user settings. Data access refers to the ability to view, modify, export, or delete information, sometimes down to individual records and fields. These layers are related, but they are not the same, and beginners often underestimate how much risk hides in data access compared to application access. A user might have limited application permissions, but still be able to export sensitive data if data-level controls are weak. An administrator might have system-level privileges that can bypass application logic entirely, which means their responsibilities and rights must be treated as especially sensitive. Architects therefore map roles and responsibilities across these layers so that the access story remains coherent. What the person needs to do, which system capabilities support that, which application workflows support that, and which data elements are required. If the mapping is incomplete, you get gaps where one layer becomes the unintended backdoor into another. This layered view also improves auditability, because reviewers can see not only that someone has access, but why that access exists in the context of their responsibilities. Roles are often the visible part of this mapping, but the quality of roles is what determines whether the model stays manageable. A role should be defined with a clear purpose, a clear set of responsibilities, and clear boundaries, including what the role should not do. When roles are created casually, they tend to overlap, and overlapping roles create confusion about where rights should live. A common beginner misconception is that more roles automatically means better least privilege, but too many roles can create role sprawl, making it hard to assign correctly and hard to review. Another misconception is that one broad role per department is sufficient, but that often leads to rights being too broad because departments include multiple job functions. Architects aim for roles that match stable job functions and key workflow responsibilities, not organizational politics or temporary projects. They also design role hierarchy carefully, because senior roles often include additional responsibilities, but adding responsibilities does not always mean adding all subordinate rights. In some cases, senior roles should approve actions without performing them directly, which is a separation of duties decision. For beginners, the takeaway is that roles are a modeling tool, and like any model, they can become misleading if the definitions are sloppy. Rights are where the mapping becomes concrete, and rights are often more detailed than beginners expect. Rights are not only read and write, they include create, approve, delete, configure, delegate, export, and administer, and each of these actions can have different risk levels. Rights also often depend on scope, such as which projects, which regions, or which data categories the right applies to. A right that seems harmless in one context can be dangerous in another, such as export rights on sensitive data sets. This is why architects avoid granting broad rights like global administrator when the responsibilities do not truly require it. They also avoid rights that allow creating new rights, because that is essentially permission to bypass the authorization model. Another important idea is that rights should often be bundled into access packages aligned with responsibilities, because assigning individual rights becomes unmanageable at scale. However, the bundles must be designed carefully so they do not become oversized catch-alls. A good rights design includes clear descriptions of what each right enables and what the intended scope is, because those descriptions support review and governance. For beginners, it helps to think of rights as the verbs an identity can perform, and those verbs should correspond to the tasks the role is responsible for. Responsibilities often feel softer than roles and rights, but they are what makes the mapping defensible. A responsibility is not just a task, it is accountability for an outcome, and that accountability often comes with expectations about how work is performed safely. For instance, someone responsible for approving changes might not be responsible for implementing them, and that distinction is critical for separation of duties. Someone responsible for handling sensitive data may be responsible for protecting it from disclosure, which implies they should not have unrestricted export capabilities unless there is a controlled reason. Responsibilities also include stewardship responsibilities, such as maintaining role definitions, maintaining access packages, and reviewing entitlements, because someone must own the access model over time. Beginners sometimes assume responsibility is purely organizational, but in secure architecture, responsibilities should be reflected in system controls. If someone is responsible for reviewing access, the system should grant them the right to perform reviews and to see enough information to make review meaningful, while still restricting them from granting themselves privileges. If someone is responsible for incident response coordination, they may need rights to view logs and disable sessions, but not necessarily to administer production systems. The mapping is successful when responsibilities can be fulfilled without requiring blanket privileges. Mapping across system access requires special attention because system-level rights can become a path to bypass application and data controls. If someone can administer servers or databases directly, they may be able to read or modify data without going through application authorization. That means system-level roles must be designed with narrower scopes and stronger governance, especially for administrative tasks. For example, a system operator might be responsible for keeping services available and patched, which implies rights to restart services and apply updates, but not necessarily rights to read application data. This is why architects often separate operational responsibilities from data stewardship responsibilities, even if both groups are part of the same technical team. Another important concept is privileged elevation, where a person operates with low privileges most of the time and elevates only when necessary for a specific task, reducing exposure. The mapping must also account for non-interactive identities, such as automation that performs system tasks. Those identities should have rights aligned with their narrow responsibilities, because a powerful automation account can be exploited silently. For beginners, the key lesson is that system access is powerful and must be mapped to responsibilities with extra care to prevent unintended data exposure. Mapping across application access requires understanding workflows and states, because applications often have approval flows, draft states, and business rules that define what is safe. An application role like approver should be able to review and approve, but not necessarily to create and then approve its own submissions, because that violates separation of duties. An application role like editor might create content, but might not publish without review. An application role like customer support might view user records, but might not change security settings or export data. These examples show that application rights should be aligned with how the business process is meant to work, not just with technical capability. A beginner mistake is to map application access at too high a level, such as granting admin, because it is easy, which bypasses workflow controls and makes auditing hard. Architects instead identify the key actions and map them to roles that align with responsibilities, using the application's authorization features to enforce the workflow. They also consider how application access interacts with external systems, such as whether a user can trigger integrations that expose data. The mapping is strong when application roles reinforce the intended process and prevent single identity end-to-end control of sensitive actions. Data access mapping is often the hardest because data has categories, sensitivity levels, and usage contexts that change over time. A person might need access to a customer's account record, but not to the customer's full identity details. Another person might need access to aggregated reports, but not to raw sensitive fields. A third person might need to update certain fields, but must never delete records. These are data-level distinctions, and they matter because the greatest harm often comes from data exposure, not from a single system action. Architects therefore map data responsibilities to rights like view, modify, export, and delete with careful scoping, often using classification and tagging concepts to define which datasets are sensitive. They also consider purpose limitation, meaning access should align with a legitimate need, and broad access should be avoided even if technically convenient. Another factor is auditing, because data access often needs strong traceability, who accessed which records and why. Beginners sometimes assume that if a user is allowed into an application, data access is implicitly safe, but applications often contain many data sets with different sensitivities. Strong mapping treats data as its own layer of authorization, ensuring that roles align with data stewardship responsibilities and that rights are granted at the minimum necessary scope. One of the most important design decisions in mapping is how you handle exceptions and temporary responsibilities, because real organizations constantly have unusual needs. If exceptions are handled by permanently expanding a role, the role will quickly become bloated and lose meaning. A better approach is to use time-bounded rights or temporary access packages that expire automatically unless renewed. This supports least privilege without blocking legitimate work. Exception handling also needs governance, such as requiring stronger approvals for sensitive exceptions and recording the reason and duration. Another pitfall is allowing informal delegation, where one user shares access by sharing credentials or by adding someone to a group without oversight. That behavior undermines mapping because it bypasses the responsibility to rights logic. Architects therefore design delegation controls that allow legitimate delegation in a controlled way, such as allowing a manager to delegate a task without delegating broad privileges. They also build in review processes that focus on exceptions, because exceptions are high risk and more likely to become orphan access later. For beginners, the takeaway is that exceptions should be visible, bounded, and reviewed, or else they become the hidden majority of your access model. Finally, a strong mapping requires that roles, rights, and responsibilities remain consistent across the environment, which means you need a governance layer that maintains definitions and ownership. Someone must own each role and each access package, and ownership includes keeping the role's responsibilities current, keeping its rights aligned with those responsibilities, and responding to changes in systems and business processes. Reviews should validate not only individual assignments, but also the role definitions themselves, because a role that has drifted can undermine least privilege for everyone in it. Mapping also depends on good identity data, because if a person's role or department is wrong, their role assignment may be wrong. That connects back to joiners, movers, leavers, and identity proofing, showing that authorization design is part of a larger identity system. Monitoring can also support mapping by revealing unusual access patterns, such as a role that rarely uses a powerful right, which may indicate the right is unnecessary. Over time, this feedback loop allows the access model to become cleaner rather than more tangled. For beginners, the key is to see mapping as both a design activity and a maintenance activity, because roles and rights are not set once and forgotten. They need stewardship to remain meaningful and safe. Mapping roles, rights, and responsibilities across system, application, and data access is about turning organizational intent into precise, enforceable permissions without creating dangerous overreach. Roles provide a structured way to represent stable job functions and workflows. Responsibilities define what outcomes those roles are accountable for, and rights express the exact actions and scopes needed to fulfill those responsibilities. System access mapping must be especially careful because system-level rights can bypass application and data controls, while application access mapping must align with workflow steps and separation of duties. Data access mapping often requires the finest control because data sensitivity varies and because export and deletion rights can create major impact. Good designs handle exceptions through time-bounded access rather than bloating roles, and they maintain the model through governance, ownership, and review so drift is corrected rather than ignored. When you can explain why a particular right exists as a direct support for a responsibility, and why the role boundaries prevent both over-access and under-access, you are demonstrating the architectural reasoning this certification expects. The deeper lesson is that authorization is not merely about permissions. It is about aligning power with accountability so that systems remain safe, usable, and explainable as people, applications, and data evolve.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.